All right, let's get our hands a little dirty today, huh? We're going deep on soil
Oh, yeah.
with chapter 1 of Deep Roots. The subtitle is A Practical Handbook on Soil Health, Fertility, and Its Use in Construction. I've always just thought of soil as, dirt, but this book is making me rethink things.
Yeah.
There's a whole world under our feet.
It is a whole world, and this chapter is a good intro
Yeah.
to understanding it all.
Yeah, and speaking of introductions,
Yeah.
this is something I've always wondered about. You know those layers you see in a roadside ditch?
Mm-hmm.
Section 1.1 calls them soil profiles and horizons.
Right.
Is it really like a slice of cake?
Yeah, that's actually a pretty good way to think about it.
Okay.
Each layer or horizon tells a different part of the story. Imagine you're digging a hole. The top, the icing, is the O horizon. It's mostly decomposed leaves and organic matter.
So that's where all the good stuff is.
It is.
Okay.
It's nature's compost pile, you could say.
Okay, and then as you dig down a little more,
Then you hit the A horizon, the topsoil. This is where most plant roots grow. And it's full of life, microbes, worms, you name it.
it's like a whole city down there.
Exactly.
I can just picture it.
It is.
All right, and then what's under that?
Under that is the B horizon, or subsoil. It's like the storage level for the soil. Minerals and nutrients get leached down from the topsoil over time and end up here.
Leached.
Ah, good point. Leaching is kind of like a slow drip coffee maker.
Okay.
Water moving through the soil dissolves minerals and carries them down. The B horizon often looks different because of all the stuff that's been deposited there.
Oh, okay, so it's like almost like a filter in a way.
Yeah, you could think of it that way.
Okay, so are we down to bedrock yet?
Not quite. We still have the C horizon.
Okay.
It's the weathered remains of the original rock the soil came from,
Okay.
like the foundation of a house, but for soil. Then finally, we hit the R horizon, the bedrock. No more digging after that.
Wow, so much going on in those layers. But how does knowing this help us in the garden?
Knowing your soil profile can tell you a lot. Drainage, nutrient availability, even the history of your land. For example, a thick O horizon means you've got a lot of organic matter, great for growing almost anything.
Right.
But a thin O horizon, like you might find in a desert, tells you you'll need to add organic matter.
So it's like a clue for what we need to do.
Exactly.
Okay, so even if you have great topsoil, what about the actual stuff it's made of?
Right.
Section 1.2 talks about soil, texture, structure, and composition. Is it really like a recipe?
It is. Think of sand, silt, and clay as the basic ingredients, just like flour, sugar, and butter in baking. Different combinations create different textures and properties.
That's why I probably haven't had the best luck growing some plants.
Oh.
My soil is really heavy clay.
Oh.
It's a workout every time I try to dig.
Yeah, clay can be tough. Clay particles are tiny and packed together tightly. They hold on to water and nutrients, which is good, but they also make the soil really dense.
And slow to drain. Yeah.
Yeah.
That's why my plants drown. What can you do about that?
Adding organic matter, like compost, can really help. It breaks up the clay and improves drainage. It's like adding air pockets.
Okay, that makes sense. What about sand?
Sand has the largest particles. It drains super fast, which can be good for certain plants, but it dries out fast too.
Mm-hmm.
So you'd have to water more often. And silt, well, it's somewhere in between.
Yeah, right in the middle.
Yeah. Silt has medium-sized particles, so it's good for water retention and has decent fertility. It's often considered the best texture for a lot of plants.
So it's about finding the right balance for what you're growing.
Exactly.
But the book also talks about soil structure. What's the difference between texture and structure?
Oh, that's a good question. Texture is about the proportions of sand, silt, and clay, like the basic ingredients, right?
Mm-hmm.
But structure is how those particles are arranged. It's kind of like how you can bake those ingredients into a cake or into cookies.
Oh. Okay, so even if you have a good texture,
Yeah.
the structure could be messing things up.
Exactly. The ideal structure is granular. The particles clump together in little crumbs, which makes spaces for air and water.
Okay.
But if your soil is compacted or has a platy structure, water and roots can't move through it easily.
This is making me rethink my entire gardening plan.
Yeah.
What about the other stuff in soil, the composition?
Ah, now that's where things get even more interesting. Soil composition is everything else. Minerals, organic matter, and all the living things in it. It's a whole ecosystem.
Wow. Okay, so we've got layers, texture, structure, composition.
Right.
Is there anything else we need to know before we start planting?
Oh, yeah, one more crucial thing. pH.
Oh, right, pH.
Section 1.3 is all about soil, pH, and nutrient availability. It's about getting the chemistry right for your plants.
Yeah, I vaguely remember pH from high school chemistry. It measures acidity and alkalinity, right? But what does that have to do with soil?
Just like our bodies need a balanced pH, so do plants. Most plants prefer slightly acidic to neutral soil, around a pH of 6 to 7.
So if the pH is, they can't get the nutrients they need.
That's right. If it's too acidic, some nutrients get locked up. If it's too alkaline, other nutrients become too available, and that causes problems.
So it's all about balance again.
Yeah,
Is there a way to test the pH at home?
There are DIY kits,
Okay.
but for a more accurate reading, it's best to send a sample to a lab. They can tell you about specific nutrients, too.
Okay, I'm adding soil tests to my to-do list. Before we get into all that, though, there's one more thing I'm curious about. Organic matter.
Yeah,
Section 1.4 makes it sound like the superhero of soil.
it kind of is.
Why is it so important?
Well, organic matter is made up of decomposed plants and animals, and it does wonders for your garden. It improves structure, helps hold on to moisture, provides nutrients, and even helps the microbes,
So it's like a natural fertilizer and soil conditioner all in one.
pretty much. And here's another cool thing. Organic matter helps fight climate change by storing carbon.
Wow, I had no idea. So how do we get more organic matter in our gardens?
Lots of ways. Composting is great. It recycles your kitchen scraps and yard waste. You can also use cover crops, plants specifically for soil health.
So instead of leaving the soil bare over winter,
Mm-hmm.
I could plant something helpful?
Exactly. And don't forget about mulch. Adding mulch helps retain moisture, stops weeds, and as it breaks down, it turns into organic matter.
It's like a triple win.
It is.
This is making so much sense. I think I know why my gardening hasn't always gone well. I've been focusing on the wrong thing. I've been ignoring the soil.
That's a common mistake. We often focus on the plants above ground, but the real action is happening below.
Well, I'm a soil enthusiast now. I'm completely converted. But is there ever a time when organic matter isn't the answer?
That's a great question. In waterlogged soils where there's not enough oxygen, decomposition slows down, and that can cause other problems.
So even the superhero of soil has its limits.
It
It
does.
sounds like understanding your specific soil is key.
Yeah, it is. Soil isn't one size fits all. Pay attention to the layers, the texture, the pH, the organic matter, and you can create the perfect environment for your plants.
This deep dive into soil has been eye-opening. I can't wait to get out there and start applying what I've learned. But before I dig up my whole garden, what really stood out to you in this chapter?
What stands out to me is how much we can learn just by observing the soil. It's like detective work. You can find clues in the layers, the color, the way it feels.
That's a great way to put it. I feel like I've been missing those clues.
Yeah.
I'm going to look at my garden with new eyes now.
Good.
But I'm also curious about the stuff we can't see, the microscopic world.
Oh, and speaking of microscopic, Chapter 2 takes us into the world of soil microbiology.
Ooh.
Get ready to meet the bacteria, fungi, protozoa, and even nematodes that make up the soil ecosystem.
Nematodes, those sound a little creepy. Aren't they parasites?
Some are,
Yeah.
but many are actually helpful.
Okay.
They're part of the soil food web, helping break down organic matter and cycling nutrients. Tiny recyclers, keeping everything balanced.
So not all nematodes are bad guys.
Not at all.
Okay, good to know. What about the other microbes? What do they do?
Microbes are essential. They break down complex organic matter into stuff that plants can use.
Oh,
It's
yeah.
like a microscopic composting operation.
So they turn kitchen scraps into plant food.
Exactly. Some bacteria can even fix nitrogen from the air
Oh.
and make it available to plants.
Okay.
This is especially important for legume plants like beans and peas.
Right.
They have a symbiotic relationship with those bacteria.
So by supporting those microbes, we help our plants.
Exactly.
How do we do that?
One of the best things is adding organic matter.
Mm-hmm.
Compost, cover crops, mulch, all of those.
So it's all about feeding the soil, not just the plants.
That's right.
Do all the microbes live in the same part of the soil?
Good question. Most activities in the topsoil,
Okay.
where there's more oxygen and organic matter,
Right.
it's prime real estate for microbes.
Makes sense. So deeper down, there are fewer.
Exactly.
But it's not lifeless down there, right?
No, not at all. Different microbes have adapted to the deeper soil.
Okay.
It might be slower, but they're still breaking down minerals and cycling nutrients.
It's amazing how life finds a way.
It is.
Speaking of different microbes, the book mentions mycorrhizal fungi.
Ah, yes.
What are those?
Mycorrhizal fungi are fascinating. They partner up with plant roots
Okay.
They extend the reach of the roots and help them access water and nutrients.
It's like a network for plants.
Exactly. It's
Yeah.
a win-win. The fungi get sugars from the plants, and the plants get nutrients and water from the fungi.
So it helps especially in nutrient-poor soil.
Exactly. It's like an extension of the root system.
Can you see mycorrhizal fungi in the soil?
Sometimes you can. Look for the threads, called hyphae, on the roots.
Okay.
They look like fine white strands.
Okay, I'm going to be looking for those now. This is all really cool, but it's a lot to take in.
It is.
What are some simple things we can do to help these fungi?
Avoid tilling too much.
Okay.
It disrupts the networks.
Right.
And use natural pest control instead of fungicides.
Okay.
Fungicides can harm the good fungi.
So it's about being mindful of what we're doing in the garden.
It is.
But how do we know if our soil is actually healthy? Is there a test for that?
That's where the next chapter comes in.
Okay.
It's all about assessing soil health, going beyond just looking at the surface.
Okay, I'm ready to put on my detective hat again.
Great.
Let's get into those assessments. All right, let's get down to business. Chapter 3 of Deep Roots is all about assessing soil health. It's like giving our soil a checkup. Where do we even begin?
It's a lot like going to the doctor. You look at the whole picture, the physical, chemical, and biological aspects.
Okay, so the physical. First we talked about structure, how the particles are arranged.
Yeah.
Can we tell if the structure is good just by looking?
Yeah, good observation is key. Take a handful of soil and crumble it. Does it break apart easily into crumbs?
Okay.
That's a good sign.
So it sticks together in a ball, that's bad.
Exactly. Good structure means air and water can move through it easily. And that's crucial for roots and microbes. You can also look for clues in your garden. Are the plants struggling?
Right.
Is water pooling after it rains?
Yeah.
Those could be signs of bad structure and compaction.
It's like the soil is trying to send us a message.
It is.
The book mentions a ribbon test for texture. What's that?
It's a simple way to see how much sand, silt, and clay you have. You try to form a ribbon of moist soil between your fingers.
And the longer the ribbon, the more clay.
That's right. A long ribbon means lots of clay, which can mean compaction and drainage problems. Knowing your texture helps you pick the right plants and stuff to improve the structure.
Okay, so we've checked the structure, but what about compaction itself?
Sometimes you can literally feel it. Try pushing a screwdriver into the soil.
Okay.
If it's hard to get in, that's compaction. You can also see if plants are stunted or if the roots are growing sideways.
They're looking for an easier path.
Exactly. The book also mentions a penetrometer.
What's that?
It measures compaction at different depths.
Yeah.
It tells you how much force it takes to get through the soil.
So more force equals more compaction.
Exactly. And once you know how bad it is, you can fix it. Add organic matter, aerate the soil.
I want to go test my garden right now.
Yeah.
But before I do, how do we check the chemical side of things?
That's where soil testing comes in. It's like a blood test for your soil. It'll tell you the pH and the levels of nutrients.
Like nitrogen and phosphorus.
Exactly.
What about those DIY test kits from the garden center? Are those good enough?
They can give you an idea, but for a really good analysis, you need a professional lab.
And they can tell you exactly what the soil needs.
Exactly. They'll give you recommendations for amendments or fertilizers, all based on your soil type, your plants, and what you want to grow. It takes the guesswork out.
This has been amazing. I can't believe how much goes into soil.
It's fascinating, right? And
Yeah.
we've only just started. Deep Roots has a lot more to offer.
Wait, there's more?
There's a whole lot more on water management, choosing the right plants, even using soil for construction. It's all connected.
Well, I think we've given our listeners a good start on soil science.
I think so too.
Any final words of wisdom for our new soil enthusiasts?
Remember, soil is alive. By understanding it, we can make good choices for our gardens, our communities, and the whole planet. So get out there, get your hands dirty, and start exploring.
Happy digging, everyone. All right, so we're putting on our detective hats again for Chapter 3. It's all about assessing soil health. It's like giving the soil a checkup. But how do we actually do that?
Well, you want to look at the whole picture. Like we said before, the physical, chemical, and biological.
Right, okay. So starting with the physical, earlier we talked about structure, how the particles are arranged. But how can we tell if the structure is good just by looking?
Just looking can tell you a lot. Grab a handful of soil and crumble it. Does it break apart easily into small crumbs? That's what you want to see.
So if it makes a hard clump, that's no good.
Exactly. Good structure means there's space for air and water to move, which is what roots and microbes need. You can also look around your garden. Are plants having trouble growing?
Yeah.
Does water pool up on the surface after rain? Those are signs of bad structure and compaction.
So it's like the soil's trying to tell us something.
Exactly.
The book also talks about a ribbon test for texture. What is that?
The ribbon test is a way to see how much sand, silt, and clay you have. Take some moist soil and try to form a ribbon between your fingers.
Okay.
The longer the ribbon, the more clay you have.
So a long ribbon means trouble.
Not necessarily, but it does mean you have more clay, which can lead to compaction and drainage issues. So knowing your texture can help you choose the right plants.
Right, so we've checked the structure. What about compaction itself? How can we tell if it's too compacted?
You can actually feel it.
Oh.
Sometimes, try pushing a screwdriver into the soil.
Okay.
If it's hard to penetrate, that means it's compacted. You can also look for stunted plants or roots growing sideways.
Because they can't go straight down.
Exactly. The book also mentions using a penetrometer.
What's a penetrometer?
It's a tool that measures compaction at different depths. It tells you how much force you need to push through the soil.
So more force means it's more compacted.
That's it. And once you know how bad it is, you can do something about it. You can add organic matter or aerate the soil like we talked about before.
This is making me want to go test my soil. But before I do, how do we assess the chemical side of things?
That's where soil testing comes in. It's like a blood test for your soil. A soil test can tell you the pH level and the nutrient levels.
Oh, okay, like those little test kits you can buy at the garden center.
Those can work, but for a really accurate reading, it's best to send a sample to a lab.
And they'll give you specific recommendations.
Exactly. They'll tell you what your soil needs based on your soil type, the plants you want to grow, everything. They take out all the guesswork.
This deep dive into soil has been incredible. I can't believe how much I've learned about dirt.
It's pretty amazing, right?
It is. There's so much going on beneath the surface.
Absolutely. And the cool thing is that all this knowledge connects to so many other things, like we've talked about, gardening and construction, but also to bigger things like climate change and the health of our planet.
Wow, that's a great point.
Learning about soil can really change how you see the world.
I think that's a perfect note to end on. So to all our listeners out there, get curious, get your hands dirty, and start exploring the amazing world beneath your feet.
Happy digging, everyone.